Hello everyone, my topic is deterioration of organic coatings on concrete under artificial aging. I'm the reporter Haochuan Wang from Southeast University, China. My tutor is Professor Chang Wenmiao and Dr. Pan Feng. My presentation including 4 parts. Background, experimental part, here is aging procedure, and results and conclusions. We all know the importance of durability problem of reinforced concrete, and it is when the concrete structure is exposed to this harsh environment, like marine or salt lakes. The variation of temperature or humidity and the high level of salt are the main factors we should consider. To overcome these bad environmental conditions, scholars and engineers have made a lot of efforts. There is a relatively cheap and efficient way that is applying organic coatings on the surface of the concrete. However, organic materials are usually easy being aged. Coatings are no exception. So, assessing the state of coatings is important in evaluating the whole durability of concrete structure, and we can recover the coatings in time. In order to aging the coatings on large-scale concrete samples, we made up an ultraviolet aging box to continue following study. This is because our normal concrete samples, side lengths of 100 mm, cannot be placed in this specialized equipment using for aging coatings. After aging, 3 parts characterization of coating are carried, including the assessment of coating surface and the interior structures, and the protection performance. Let's see some details in experiment procedures. We choose 2 kinds of coatings, epoxy resin and polyurethane resin. These 2 coatings are widely used in now engineering applications. After curing, the set of aging is here. 4 hours ultraviolet irradiation and then 4 hours condensation. Every 8 hours is a cycle. And in condensation part, we use sprayer to cool down. In irradiation step, the temperature can up to 55 degrees and the relative humidity would decrease below 10%. Then, in condensation step, the temperature back to room temperature and the relative humidity is close to saturation. After aging, let's look at the surface characterization first. Under the scanning electrical microscope, we can see that, as aging goes, there are more defects appear on coating surface. The epoxy resin deteriorates more obviously. We know the organic coatings usually have a good resistance to water, but under aging, this performance gets worse. It is apparent that the water contact angle decreased and epoxy resin decreased faster. In order to find out the cause of surface deterioration, we carried the Fourier transform infrared spectroscopy on coatings. Both epoxy resin and polyurethane, there are some changes on function growth intensity. For polyurethane, the phenomenon of breakage of Euro group and chain section were observed. But after aging 480 hours, the chains are little. This proves the polyurethane materials are relatively stable under long time aging. But when it comes to epoxy resin, the changes are severe. The most clear is the increased peak of hydroxyl and carbonyl in saturated aldehyde or ketone. This indicates the oxidation of epoxy resin, and these are all hydrophilic function group. So we can explain why the water contact angle decreases. Next is the internal structure. In water absorption test, both epoxy and polyurethane coatings show the same upward trend, indicating that the increasing number of pores or free volume and water can pass through these pores. The same as before, polyurethane is more stable than epoxy resin. But there is a decline at 440 hours of epoxy resin. This is related to the post-curing of epoxy, resulting in a denser surface. Of course, we want to find some evidence that supports the pore in internal structure really increased. We analyzed the cross-section picture of coatings and using image processing to obtain the pore ratio. We first adjust the geometry and the gray level of the image. Set a gray value as the threshold to distinguish pore and solid phase, and then count the pore ratio. Porosity of epoxy coating increases over aging time, while polyurethane coating stays near zero. And we can find a denser surface on coating resin. This confirms the existence of recombination and post-curing. Although from the structure evaluation we can find the weathability of polyurethane is better, but things are different when assessing the protective performance. The reason is the poor bonding property of polyurethane. Look at the left figure. The bonding strength is reducing with aging time, and the failure mode of epoxy resin changed from the concrete matrix fracture to the interface debonding. But the failure mode of polyurethane are always the breaking debonding at interface, because the bonding strength keeps at a low level. Due to this performance, polyurethane do not show a good protection as the weathability. From the salt solution immersion result, first we can find that whichever the coating can both significantly reduce the chloride aggression for at least one order of magnitude, while the epoxy resin don't change too much after aging. For polyurethane, after aging, there is a sharply increasing of chloride content, almost 20 times. This because the water passed through the polyurethane coating and accumulated at interface area, leading a continuously weakening performance. So far, combining the degradation and protection of coating, we obtained an evaluation system. Look at the picture. The increase on both hydrophilicity and the defects on coatings surface is related to the change of chemical structures, and it is caused by ultraviolet irradiation. The pore and free volume increase, so the water absorption increase, and the invasion of water keeps weakening the interface and reduce the resistance to the chloride. Here are the conclusions. Through the surface and the internal structure, characterization, we can obtain the weathability. Fourier is better than epoxy. But adhesive strength and long-time resistance to chloride, epoxy resin is better. This reminds us, when evaluating coating under aging, bulk degradation and interface performance are both vital. So this is my report. Thank you.